Welcome to this tutorial of electrostatics. This is the third section, and we're going to be looking at some terminologies, and also we're going to be solving questions under this electrostatics. Firstly, we're going to begin with electric field. So what is the definition for electric field? Electric field is a region of space where electric force occurs. So I'll just say this is the region of space where electric force occur. So electric field is also often known as force over charge. So when you are dealing with electric field intensity, you can either call it electric field intensity or electric field. So it is known as force over charge. So and the unit of that, force is in Newton, while charge is in coulombs. So that is Newton per coulombs. So that's for that. We also have electric potential. So what is electric potential? It's the energy required to bring a unit positive charge from infinity to the against the field action. So this is the energy required to bring a unit positive charge from infinity to a point in the field action. So and it is always known as V. So electric potential, you can also call it voltage. So what is voltage? Voltage is you can calculate voltage as ER when you are dealing with when you have electric field in the calculation, and this R is the distance. So another formula for electric potential is work done over charge. So you can also call it work done over charge when you have work done in the equation and you are given charge. So you can calculate. So it is when you have electric field intensity you are using this. So when you have work done, when you have charge, you use this formula. So and this is going to be joule per coulomb. Joule per coulomb is the formula for is the unit for electric potential. So now when we are relating E and V, what are we going to be having? I already said it here that V is equals to ER. In that way, electric field intensity will be V over R. So that means that electric field intensity can also be volts per meter. So that means this one can also be volt per meter. The unit can either be volt per meter or Newton per coulomb. So from there, I can use the law of Coulomb's law. I can insert Coulomb's law there. So I can have E is equals to F over charge. That is from here. So I can insert this force, which is KQ1 Q2 over R square. If I insert that, I'll be having E is equals to KQ1 Q2 over R square multiplied by 1 over Q. So this Q can cancel one of this Q. You have your electric field intensity to be KQ over R square. So that is another formula for electric field intensity. It's KQ over R square. So when you insert this formula we got the other time, V is equals to ER. So let V is equals to ER. So when V is equals to ER, so since E is this now, you can just put E here. So we'll be having V is equals to KQ over R square multiplied by the R. So one R will cancel another R. So the formula for electric potential, which is V, can also be KQ over R. Note that for electric field intensity, it is KQ over R square, but for electric potential, it is KQ over R. So let's take note of that. So I'm going to be going to the first question. A charge of magnitude 2 times 10 raised to the power 4 coulombs experience a force of 80 Newton in the electric field. They say we should find the electric field intensity. Now, what is the formula for electric field intensity? we already know that it is force over charge. So this is a direct question. You just have to write um electric field intensity force over charge. We have our force and we have our charge. So this is 80 over 2 times 10 raised to power minus 4. And when you calculate that, we'll be having 4 times 10 raised to power 5. So we'll be having 4 times 10 raised to power 5 Newton per coulomb. Note that it's Newton per coulomb we are going to use it because it's force over coulomb charge. So we are using Newton per coulomb. Quickly, let's go to the second question. So that's the answer for this. For the second question, we have electron of charge this and it is situated in a uniform electric field intensity of this. So we are asked to find the acceleration and they gave us the mass. So when you know that there is mass and there is acceleration, we already know that it has to do with something with force because force is equals to ma, that's mass times acceleration. So and we are looking for electric field intensity. Now, which formula are we using? For this, we are going to be using, um, let's say, E is equals to F over Q. You know, we are still using the same formula. E equals F over Q. But now this F, we are going to turn it to MA. So you'll be having E equals MA over Q. And you can make A subject of formula. If you make A subject of formula, you'll be having, this one comes here, it becomes EQ over A. No, EQ over M rather. You'll be having EQ over M. So then you bring all the calculation down. So you'll be having what's our E here? Our E is 1.2 times 10 raised to power 5. That's the meaning of this E. So multiplied by charge. The charge is 1.6 times 10 raised to power minus 19. Then all over, manage our space there. M. M is 9.1. So 9.1 times 10 raised to power minus 31. So when we calculate that on our calculator, our solution is going to be 2.1 times 10 raised to power 16. So we have 2.1 times 10 raised to power 16 meter per second square. You can also write it as you can also write your A as 2.1 E 16 meter per second square. So that is for this part. We're going to be moving to the next question. In this next question, they said a charge of 4 microcoulomb is moved to a point where electric potential is 250 volts. So we're asked to look for the work done. What's the formula for work done? We have a formula that says that the electric potential equals to work done over charge. So we have electric potential is equals to work done over charge. So that has to do with the Gauss laws. The Gauss laws. So you can say from here that if you make W sort of formula, you're going to be having VQ. So then we have charge, we have the electric potential, which is our voltage. So we can calculate that straightforward and say our V is 250 multiplied by our charge. This is micro, so that's times 10 raised to power minus 6. So when we calculate that, 1 times 10 raised to power minus 3. 1 times 10 raised to power minus 3 in joules, because work done is in joules. So lastly on this note, we have two charges, 5 microcoulomb and 7 microcoulomb. They are 3 meters apart. So we have something like a charge here and a charge here. Then the distance is 3 meters. Let's say this place is we have 5 microcoulomb. Here we have 7 microcoulomb. So now we are now asked to look for the electric potential. So electric potential, when it has to do with distance and charges, which formula are we using? That should be V equals to KQ over R. Remember when we deriving the formula the other time, we said V is equals to KQ over R for electric potential, but if it's for electric field intensity, that's going to be KQ over R squared. We remember. So now we are going to calculate our V1 and we are going to calculate our V2. So do we get? So now they said midpoint, at midpoint. So that means if it's midpoint, that's at the center here, and that's going to be 3 over 2, which is 1.5. So the resistance I'm going to be using is 1.5. That means our R is 1.5. So calculating for V1, we use the gravitational constant. Remember that K is 9 times 10 raised to power 9 Newton meter square per coulomb square. So we can insert that here, times 10 raised to power 9 multiplied by the charge 5 times 10 raised to power minus 6 over the radius or the distance, which is 1.5. Let's see what that gives us on our calculator. We are going to be having 3 times 10 raised to power 4 volts. 3 times 10 raised to power 4 volts. And for the second one also, our V2. So we are going to be calculating that also in the same way. So we are using this now, we are using this charge now, times 10 raised to power 9 multiplied by 7 times 10 raised to power minus 6 all over 1.5. So let's see what that gives us on our calculator. We are going to be having 4.2 times 10 raised to power 4. So 4.2 times 10 raised to power 4 volts. Now we will now look for the total. The total is going to be the sum of the two. The sum of the two is going to give us the total. So V1 plus V2, the total. So that will be 3 times 10 raised to power 4 plus 4.2 times 10 raised to power 4. And that will give us what? 4 plus, that's going to be 7.2 times 10 raised to power 4 volts. We are looking for electric potential. So that's going to be in volts. So this is our final answer, 7.2 times 10 raised to power 4. Thank you very much. This is just the third section of the electrostatics. We are still going to be doing a section more on this topic. Thank you very much. Do well to like, share, subscribe and comment.